Okay, so the first thing we're going to really do with these things is we're going to change equations that are written in one system into another. Okay, so let's suppose we have r equals sine theta. And let's graph this. Okay, now there's actually two ways that we're going to do it. So we're going to do it first. We're going to do it by changing it to an equation in Cartesian coordinates. Sorry about that. There we go. Okay, so when we change to Cartesian coordinates, we're using, again, remember, x equals r sine theta, y equals r cosine theta. So what we have is we have this, well, let me just write it. We have r equals sine of theta. So sine of theta is actually equal to x over r. Okay, so I'm going to write this now as r equals x over r. Okay, which is r squared equals, oh, why did I write that? Oh, that was totally backwards. X is r cosine theta, y is r sine theta. That's what I said before, and I don't know why in the other video, okay? I don't know why I made that mistake, but well. That's the benefit of knowing what your answer should be before you do the problem. Okay, so r squared is x squared plus y squared. And now we're going to write this. This is going to actually end up being a circle. Completing the square, we're going to have to add 1/4 to both sides. Okay, so this is a circle centered at 0, 1/2 with a radius of r equals 1/2. Okay, move this a little bit over to the side here, not far. Okay, and let me draw that. So if we draw that circle, basically going to be a circle like so. Okay, all right, now there's another way to look at this. Okay, so this is method 1. Let's take a look at method 2. Method 2 is a little bit different, but it's going to give us the same result as far as the graph goes. Okay, so method 2. So what I'm going to do, I'm going to actually look at r equals sine of theta as just the Cartesian graph. So let's look at the Cartesian graph of r equals sine theta. By that I mean, what if you put r along the y, theta along the x, all right? And I used to do this by plotting points, but I've since change to just graphing, because graphing sine function, that's not that hard, right? We all kind of know what that is, right? R equals sine theta, remember, starts at the middle, goes to the top, back to the middle, bottom, middle, right? Okay, this is pi. This is 2 pi. This is pi over 2, 3 pi over 2. Okay, so this is the Cartesian graph, but we want the polar graph. Okay, that's what this is. This is really like a polar graph. Okay, and that's the actual graph that tells you, like in terms of r and theta being what they are. Okay. Okay, so what you want to do is you want to start with the angle and then go in that direction a length of r. Okay, so when theta equals 0, r equals 0. So that's easy enough. That's this point right here. Okay, now when theta equals pi over 2, when theta equals pi over 2, that means your angle here is going to be pi over 2. It's going to go in this direction. And it's going to be out, what is that? That's 1, right? Make that bigger. So this is going to be a bigger plot. Okay, now, here's the other thing. Between 0 and theta equals pi over 2, my radius is positive, right? It's in this, it's above the axis. It's positive. So I'm going to take, that's sort of going to be this part. Okay, think about it, it makes sense, right? Because it's out in this direction. Okay, now between pi over 2 and pi, it's positive again. But what's sine of pi? Sine of pi is 0. So it's actually going to be back here again at pi. This one's not as nice, right? Okay, but what's happening here? Okay, so let's say 3 pi over 2. 3 pi over 2, that's this direction down here, right? However, the radius is negative, so that's why it goes up this way. So what happens is that this goes around twice, which you wouldn't have seen it from that method, okay? All right, we'll do another graph, another polar graph in the next video.